Welcome to Project MFG's 2026 Clash of Trades. I'm your host, Jesse Trank, Senior Applications Engineer with Mastercam. Over 50 schools participated in this season's Machining Challenge, and only 16 teams moved on to the regional rounds of qualification. Today, we're at St. Philip's College in San Antonio, Texas for the Southern Regional Qualifier. This is one of 4 stops on the road to Nationals. If you haven't seen our last 2 qualifiers of this season covering the Eastern and Western regional competitions, be sure to check them out. Only one team from each of the 4 regions will advance to Nationals for a shot to win $100,000. Get ready for some machining action. This is Clash of Trades.
Remember, precision starts at the Bucks County Technical High School.
We are Tiger Tech, and we're a very small team with a very big dream.
We're Thaddeus Stevens College of Technology, and we're here choochin' and boochin'.
We are Minnesota State Southeast. When in doubt, chamfer it out.
This year's competition is in automation. So today the teams are using Bamboo Labs 3D printers to make some of the end effector parts, but also they're going to be mainly focused on the Haas UMC 500s that they're going to be making 5 parts for the contest. At the end of the day, we got to grade these parts. So there's 4 criteria that we're using. The main one we're grading on is machining and accuracy of the part. The second one is cost. The third one is teamwork and work ethic. And the fourth one is additive manufacturing. And it might come down to 1 or 2 points to find the overall winner of this contest.
All right, good morning. Welcome to San Antonio. You guys ready? Yeah! All right, we begin in 3, 2, 1.
We competed in last year's competition, and this year we are taking a lot more preventative steps to avoid issues in the future.
So there's 3 of us here on the team. I'm doing the 3D printing right now and helping out with their programming. We have a new team each year, so it's definitely a challenge.
All right. A great strategy, secret weapon, whatever you want to call it, just get it done.
The parts are pretty complicated. My 2 teammates are actually doing most of the programming, so it's going to be nice there, but I get to run it and see if it doesn't crash.
We're 45 minutes in right on time. We're choochin' and boochin', as they say.
We're choochin' and boochin', as they say. I have no idea what it means.
This is the part we're making. It's the lower housing. Our goal is to have it done before lunch.
The probing system in this machine is all battery operated. That's including the work offset system and the tool offset system. And if they are not getting battery power, they don't communicate back and the machine errors out and you can't set your tools. They're gonna find us some new batteries and we're gonna get some credit time for this.
I'm gonna guarantee that there's gonna be mistakes made. Tools are gonna break, parts are gonna go flying. It's supposed to be just the chips that are flying.
I guess the probe's misaligned or either this tool's all the way messed up. Turns out the probe was angled like this almost, where it's supposed to be straight. So we've wasted a little over an hour now.
We're up and running now. We got the batteries in. We're on the 3/4 M mill for roughing the first side of the lower housing. So our strategy here is to finish the backside first. This will take the most amount of time. We could pump those other 2 parts out at lunchtime if we needed to. I mean, it will not take us that long.
Guys, those drill holes look awful, man. Oh, we were offsetting our wear the wrong way. That means we were telling the machine that the tool was bigger, which means it would make this hole smaller, but we wanted to make the hole a little bigger, so we had to tell the machine the tool was smaller, so.
I think the time management and budgeting is also a little scary. You know, if we break a tool, that could cost a lot.
Finally machining, kind of back on track. Here's our 1/4-inch M mill. I guess I got some snacks for later.
The chamfer mill went into the part a little too deep, so now we got to get another one. It's right there, it broke off right here. Just went a little too deep in there. We're gonna have to buy a new part for the part that we just broke, so.
St. Philip's College is a historical black college. It was started back in the late 1800s. We have the biggest and best manufacturing lab facility in the state of Texas.
Hosting competition, we get the publicity to show what we do here.
This competition really pushes our students to the next level.
We were able to use the money that we won at the competition, and we were able to buy a 5-axis machine after that.
To me, it's kind of mind-blowing, right? Because 15 years ago, I'm like, oh, I know 5 people, and now it's like, I might know 10 kids behind me. It's impressive.
We're making hole a little bit bigger so we can fit a dowel pin in it. Removing material in this hole so we can fit the pin in so we can bolt the part onto the fixture plate and finish the other side. Should be golden.
Starting the op 2, so the second side.
There you go. It just doesn't stop.
The whole point of that was to keep this on there so it's strong, but you took it off. So
You wanted to test the outside contour.
That rushing and mistakes, they're just gonna climb up into a big, massive snowball.
Where are we cutting? What path?
here, right there.
What is that? Show me the path.
Then you hit a wall and
We're probably gonna get, like he wants the one side done, then he wants to go back to the other ones, which is gonna, whatever.
You should have a good relationship with your programmers as a machinist, just because you can figure out what needs to be done differently and just make sure everything runs to perfection. 3 hours left, we're done with the valve body. Now we're going on to the harder arm part of it.
We got our first part done. We had a bit of a mishap. The end mill went right through the part. Didn't have a good clearance plane, and this one, no end mill going through the part at all. Clean part.
We have like an hour and a half left with this competition, and we think we can get to all the parts. There's a couple of features we're questioning a little bit. We're just worried about getting our parts done.
A part didn't go as planned. We didn't have enough time, so we couldn't make any changes, and that's what happens.
Will you guys come in here and clean this up, please? We have one more of those to make yet, and no time to do it.
5 minutes left. Just trying to make it work at this point. This is way out of my comfort zone.
Come on. Hurry up.
5, 4, 3, 2, 1. Shut down the machines.
That'll have to do. We're supposed to make 5 parts. We got 3 of them done. I'm pretty confident about the parts we made.
We got done with 4 parts, and 2 of them didn't get completed.
We got part of a main arm done, so it's pretty nice.
So we got 3 done. We got the main part, we got the 2 smaller parts, and we're missing the 2 larger parts.
For the judging of the competition, we're using our coordinate measure machine. We're going to use a probe to measure all the dimensions, and it'll kick out a report that we'll give to the judges. We partner with schools a lot because those are our next generations.
I love being able to see my results laid out on a paper, know what I can improve on, know what I can come back and do better next time.
Congratulations on making it to the regional finals for the 26 Advanced Manufacturing Competition. So, the team that's going to move on against the teams we already have, and the 4th team that will be decided in Wichita, is Thaddeus Stevens College of Technology.
we're a strong team. We're Thaddeus Stevens. We're choochin' and boochin' and coming for the title.
Chooch and booch! The South brought the heat and the precision. Congratulations to Thaddeus Stevens College of Technology as they move on to the national championship. Next up, there is one more region left to be decided before we move on to nationals. Stay tuned for our Midwest Regional in Wichita, Kansas.